Just as liquids have special properties, measuring gases has some specific information that you'll need to learn. First of all, when we measure gas, we look at its volume. We measure its volume in cubic units, and it's important to note that gases will always have the same volume as its container. When we talk about the temperature of a gas, we look at the fact that the faster the particles are moving, the greater their energy and the higher their temperature. So a thermometer is almost like a speedometer for molecules, how fast they are moving, just like a speedometer measures how fast a vehicle is moving. At room temperature, the average speed of particles is about 500 meters per second, which is actually more than twice the speed of a jet plane. So that gives you an idea for how fast gas particles are moving just at room temperature. Here I have slow particles, and you can see that I drew them with just little arrows showing they're not moving very fast. Those would be cooler than the fast-moving particles that are moving around and bouncing off of the wall. Pressure. The pressure of a gas is the force of its outward push divided by the area of the walls of the container, and we measure that in units called pascals, which is abbreviated a capital P and a lowercase a. The firmness of a gas-filled object comes from the pressure. So the air that's pumped inside a ball actually has higher pressure than the air outside. So when we think about pressure, think about a fully inflated basketball. We would calculate the pressure by measuring the force of the gas that's pushing outward by the area of the interior surface area of the walls of the ball. And we would define that in pascals. So high pressure means that there's a high number of gas particles per unit volume. So here I drew a ball that is filled with gas particles, because the more gas particles there are inside of that ball, the more they're bouncing against each other, bouncing against the wall, and then ultimately pushing out. Low air pressure is related to a lower number of gas particles per unit volume. So in that same ball, you may have less gas particles, which means they're bouncing against each other and against the wall less frequently, with less intensity, and ultimately pushing out less. It's also important for us to study and look at how temperature and volume are related when talking about gases. The first law that helps us investigate this is Charles' law. Charles' law is that when the temperature of a gas is increased at a constant temperature, at a constant pressure, its volume will increase. So that means when the temperature of a gas is decreased at a constant pressure, its volume decreases. So let's look at this. If we take a balloon that's inflated, such as this, and it's at room temperature, which is about 22 degrees Celsius, and then we cool that balloon, and therefore the gas that's inside of it, to 0 degrees Celsius, what you can see is that the size of the balloon actually has shrunk, because now the gas particles are moving less slowly, they take up less room, so they're closer together. They're not pushing out in the same way. If we keep cooling it to negative 196 degrees Celsius by putting it, for example, in liquid nitrogen, you can see that it will shrink even smaller. And then when we heat it back up again to 0 degrees Celsius, it will increase in size because now those particles are moving faster, they're taking up more space. And finally, if we allow it to go back to room temperature, it would go back to the original size because now the gas particles are moving. So Charles' law is related to temperature. When you increase the temperature, you increase the volume. When you decrease the temperature, you decrease the volume. And you can see here in this little chart, I wrote temperature and volume. So if the temperature increases, the volume increases. If the temperature decreases, the volume decreases. And we can say that this is a directly proportional relationship. In a directly proportional relationship, the graph of two variables will create a straight line passing through the origin because the variables are directly proportional to each other, meaning that if one of these increases, so does the other. You can see here in this chart of Charles' law that as the temperature, now we're actually measuring it here in degrees Kelvin, which is why it's a K, but as the temperature increases, you can see that the volume that the gas is taking up also increases. So that's what makes it directly proportional. As one increases, the other also increases. Likewise, as something decreases, or the temperature in this case, the volume decreases. Boyle's law is the second law that we need to look at when we discuss gases. Boyle's law states that when the pressure of a gas stays at a constant temperature, when the pressure of a gas that's at a constant temperature increases, so when we add more pressure, the volume of that gas decreases. And when the pressure is decreased, then the volume increases, assuming that we're not changing the temperature at all. So for example, if you've ever had a bike and you've used a bike tire inflator, you'll have experienced this. As you push down on the plunger of the bike pump, the volume of the air that's inside the pump gets smaller, and the pressure inside the cylinder increases, because what you're doing is you are reducing the amount of space that it has, which now means that there is less surface area for it to push out on, which increases the pressure. This increase in pressure forces ultimately the air into the tire. So here you can see we made the same chart as we did for Charles' law with pressure and volume, only this time we're looking at pressure, not temperature. So as pressure increases, the volume decreases. You could also look at it as the volume, if it decreases, the pressure increases. And if the volume increases, then the pressure decreases. This is an inversely proportional relationship because in this case, the two variables are inversely proportional to each other, which means that as one of them increases, the other decreases. And we can see that looking here. You can see that the pressure is decreasing as the volume increases, which is why we get this curve. Now, increasing temperature raises pressure. When the temperature of a gas at a constant volume is increased, the pressure of the gas increases. When the temperature is decreased, the pressure of the gas decreases.